Hi everyone, so we're going to start our trigonometry unit, taking a look at similar triangles part 1. Our goal is to understand the properties of similar triangles and use them to find the lengths of missing sides in similar triangles. So first off, just kind of a definition and some background here. When two triangles have the same shape but are different sizes, we're talking about similar triangles. And two triangles are similar if the corresponding angles are equal, and if the corresponding sides have the same ratio. Okay, a little bit more about the notation with similar triangles here. We'll just make a note here. So here it says, if triangle ABC, and that symbol, that wavy line, means is similar to triangle PQR, then we know some things. So then we know that angle A is equal to angle P. They have to be exactly the same size. Angle B is equal to angle Q. Angle C is equal to angle R. So those are the angles. They're all equal. The corresponding angles are equal. And then the corresponding sides have the same ratio. So that means that the side AB is in a ratio with PQ. BC is in a ratio with QR. And AC is in a ratio with PR. And all of those ratios would be equal to one another. And the big thing here when you're writing the ratios is please make note of the fact that all of these sides that I have on the top of the ratios all come from the same triangle. So if we want to, we could say that they're all coming from the big triangle. These guys in the bottom are all coming from the small triangle. And it doesn't matter where you put them, on the top or on the bottom, but all of the sides that are with the big triangle have to go together on the top or the bottom, and same thing with the small triangle numbers. Now I also want to make note up here when we have a statement like triangle ABC is similar to triangle PQR, the order it is written in matters. And here's what I mean. The angles that look the same in the two triangles, so basically the angles that are equal to each other, should be in the same position. Oops, not forget my E there. Same position. So if we take a look at our statements back over here, the A comes first here, the P comes first here, and their two angles are equal to each other. The B comes second, the Q comes second, and B and Q are angles that are equal to each other. And the C comes last, the R comes last, and the C and the R angles are equal to each other. So the order that we write those letters in is very important. That has meaning. Now, if we want to try and prove that two triangles are similar, you can do one of two things. You can prove all angles are equal. And if we use that proof, we would use AAA as our reason for angle, angle, angle. And our other option is to prove that all three corresponding sides have equal ratios. And if we use that method to prove that the triangles are similar, then we use SSS for side, side, side. So let's take a look at some examples here. Move this guy up. All right. So for each of the following, try to prove that the triangles are similar. If they are, make proof statements. So in the first pair of triangles here, we've got triangle PQR, we've got SUT. Now, the 56 and the 34 are not equal to each other, but if I want to try and figure out what angle R is here, angle R is going to be equal to 180 minus 90 minus 34. And when I do that calculation, I get 56 degrees. So what that means then is that this angle is 56 degrees, and then this angle in the other triangle is going to have to be 34. And so now we know that these two triangles are similar. We can say angle U equals angle Q, because they're both a 90-degree angle. I can say angle S, that's 56 here, is equal to angle R. And then I can say that angle T is equal to angle P. Notice my format here. All of the sides on this side are all from the bottom triangle here, and all the angles I have on this side are all from the top triangle here. And that makes it easier because now I'm going to say, therefore, triangle UST is similar to triangle QRP, and my reason is angle, angle, angle. All right, in the second case here, I've got an isosceles triangle here with these two sides equal, here and here. So that means that angle M equals angle N. That means that angle N is going to equal 65 degrees. So if this angle is 65 degrees, and that means that angle L is going to be 180 minus 65 minus 65. So angle L is going to equal 50 degrees. But you can see we have a problem when we compare it to the other triangle. They're not the same. So therefore, we can just say that they are not similar in this case, because all the angles are not equal to each other in those two triangles. Okay, the bottom one here, I'm going to add one more piece of information here. These two sides are parallel to each other. So HF and KJ are parallel to each other. And if that's the case, when we have parallel lines, we actually know that angle J is going to equal angle H, because we have a Z pattern there. So that angle where the H is going to be 35 degrees. So my reason here is parallel line theorem, and I'm just going to put a Z for the Z pattern. And then angle K in the triangle on the right is equal to angle F for the same reason, because I have a Z pattern here. So I know that those two angles, whatever they are, have to be equal to each other as well. And we also know that the angles in the middle here are equal to each other because of opposite angle theorem. So I got to be careful when I name that angle. I can't just call it angle G and angle G. In the triangle on the right, I would call it angle JGK is equal to, and in the triangle on the left, I would say angle HGF. Hope I didn't scare you there. And that's the opposite angle theorem. So once we know all the angles are equal, we're going to say that triangle JKG is similar to triangle HFG, and it's angle, angle, angle. All right, our last section here. So if you're given similar triangles, or you can prove that the triangles are similar, then you can solve for unknown values in those triangles. So in this example, name the similar triangles and explain why they are similar, then determine the missing values. So in our first one here, in these two triangles, we've got some angles labeled the same. We've got angle A is equal to angle F. We've got angle B is equal to angle E. And if two angles in one triangle are equal to two angles in the other triangle, then that third angle has to be equal to the third angle in the other one as well, because they all add up to 180. So because of that, we can say, therefore, triangle ABC is similar to triangle FED. Now that they're similar, we can write the ratios of sides to help solve for the unknown values. So in this case, we know that AB from the top triangle corresponds to FE in the bottom triangle. And in the top triangle, BC corresponds to ED. And the last ratio here, AC, corresponds to FD. And you can use the diagram to come up with those. You can also use the letters the way they're written here, because if they're in the proper order, then AB should be over FE. And BC should be over ED. And AC should be over FD. And so that's how I came up with that. Now I can plug in what I know. So AB is 6. FE is X, I don't know that. EC is 9. ED is 3. And then AC is 8. And FD is Y. So now I can use these ratios to help solve. So I kind of have two different ones to solve for. I've got 6 over x equals 9 over 3. So to solve this ratio, I cross multiply the two numbers and divide by the other number. So it's going to look like 6 times 3 divided by 9. And I'm going to end up with x equals 2 there. Let me just move this a little bit to give you some room. So x equals 2 is the answer there. On the other side, to find y, I'm going to cross multiply 3 times 8 and then divide it by the 9. And when I do that, I come up with 2.67. I'll just round that to 2 decimal places, and that's what I get there. Okay, and those numbers make sense in the diagram, so that's what I have for that. The last one here, so I've got 2 triangles here that are overlapping. So in triangle, actually, you know what? I'm going to stop here. We're going to do this one as a warm-up tomorrow. So we'll finish this one tomorrow in class. I've already gone on long enough here. So I'll see you tomorrow.